Thank you for joining me for the third problem of the level 3 problem set, problem 9. It reads, calculate the distance from block B to the fulcrum so that the lever remains balanced. All right, so just like the previous two ones we did, the key word in this is that we want it to be balanced, which means that whatever force and whatever torque is being created from one side of the balance needs to be equal to the other. Now, we've already done two, so we're just going to get into this. We know that the net torque, because it's balanced, needs to be equal to 0. And that means that pretty much these two torque values are going to be equal opposites of each other. So the first thing I want to do is just figure out what is it for side A. So they gave me a mass and they gave me a distance. So I'm going to need to get a force, and it's a perpendicular force, so I won't need the sine of theta in this case. And I'm going to be calculating the force of gravity, which is equal to the mass times acceleration of gravity, which is 9.81 meters per second squared. I know my mass, given there, is 12 kilograms. Times are 9.81 meters per second squared. And if I plug that into my calculator, I get 117.72 newtons. And now that I have my force, we can go calculate my torque for A, which is just the force of gravity that I just calculated, which happens to also be the perpendicular force, times the distance in this case. We're going to use the distance for A, which is equal to 2.5 meters. So now I can plug and chug. I have 117.72 newtons, and then I have 2.5 meters. And they're being multiplied by each other. So what I end up getting is 294.3 Newton meters. And the last thing I need to do is just determine the sign for that. So that is going to cause, this force is going to cause things to go counterclockwise, which means that it's going to be positive. So we'll just hold on to that for a little bit. So if I have positive 294, that tells me, since it's balanced, that the torque for B has to be equal to negative 294.3 Newton meters. And that negative makes sense because that force of gravity that's going to be generated is going to be turning the lever clockwise, which is negative. So now I just need to solve for the force of gravity not the force of gravity. I need to solve for the distance, so I'll need to calculate the force of gravity. In this case, the force of gravity is going to be equal to the mass again, which is going to be 4 kilograms, times the acceleration of gravity, which is 9.81 meters per second squared, times 9.81, and I get 39.24 newtons. Good. And now just to find the distance, I need to take my torque equals force times distance, and I've got to be consistent on the colors. Force times the distance. And I'm going to divide both sides by force so that I leave distance by itself. Those cancel. So now what I have is torque divided by the force will be equal to that distance that I'm looking for right here up above. So now I can plug and chug. My torque is 294.3 Newton meters divided by the force, which is 39.24 newtons. This is good. My newtons will cancel, so I'll be left with meters. And let's see what I get. I get 0.5 meters. Now, I'm going to just underline that. We'll see if it's my actual answer. Well, let's take a look and see if this is reasonable. I have a heavier mass on the left side compared to the right. And so since the left side mass, the mass of A, is greater, then it needs to be a shorter distance. And it is, from the sketch at least. And according to my answer, it is, because 2.5 would be smaller than 7.5. So that's good. Now, the mass of A is 3 times as much as the mass of B, because you would have to multiply 4 kilograms by 3 to get to 12, which means the distance for B should be 3 times as much as the 2.5, which gives us 7.5. So this is a good answer. I can box it, and there you have it. Thank you very much for your time, and you have a great day.